Hello, everyone. This is DeCODE, second episode. It's been a while. Hi, Alex.
I got it.
Today we're going to talk about a phenomenon rather than a particular algorithm. So this phenomenon uses a number of algorithms and they differ in sophistication. So we're going to try to give you some sort of overview of this. But to start with, the phenomenon is deepfakes, and we will go straight to first rubric, Algorithmology, where we define an algorithm or a phenomenon in our own words. So how would you define deepfakes in your own words?
Well, I think it's Hollywood's favorite tool to bring dead actors back to life.
Yeah.
Because it's possible now. And we've seen this with Star Wars.
Yeah, I think the first one was probably in The Gladiator, right? Remember,
Yes.
there was an actor that died during the filming of Gladiator.
And Fast and Furious as well.
Yeah, and so in Star Wars they used it to kind of show a younger version of a person, and also a person who was deceased. Yeah, and so to me it's kind of the tool that it helps you impersonate someone else. So could be used in a number of domains, and it's quite striking how sometimes there are tools that are used by the government that could be easily manipulated using deepfakes. For example, I remember a few years back, the tax authority in the UK used voice as a potential way to authenticate yourself.
It's a biometric.
Yeah, it's a biometric, but obviously it could be easily reproduced using technology. And for a while in Australia, I think you probably still can authenticate on MyGov using your voice, but
I don't think so.
No, not anymore anyway, but it was an option at one point to authenticate using your voice. So hopefully it doesn't allow us to do that anymore. So the system doesn't allow us to do it anymore. But so deepfakes are definitely part of our lives. I think recently there was a documentary in Australia with politicians and discussing politicians and deepfakes. This phenomenon actually affects many of us and many aspects of our lives now. With that, let's go straight into deep dive. Define the phenomenon in more detail and talk about it more seriously, I guess, kind of beyond the deceased actors. So deepfakes, in fact, existed for quite a while now. And we have quite a few ways to look at them. Right. So so you probably the most famous deepfake that we saw recently was the one that was used by the Russians to impersonate Ukrainian president, where he kind of was calling for everybody to surrender, but naturally no one from Ukraine believed.
Given the context, it was hard to believe. Yes.
Yeah, given the context, it was hard to believe, and I don't think it worked since. So if we look at benign use of deepfakes, the one example that I could think of is modulate. So this is in a game environment you can basically use a deepfake to pick up your to use a voice skin to kind of use a different type of voice.
You can sound like Obama, or you can sound like your favorite actor,
or your favorite animal.
Often, yes.
Yeah. So yeah, it just depends on what you want. Yeah, but most of the time we're talking about malicious deepfakes, and it kind of is rooted in propaganda. I quite like this example because this is example of how Russian propaganda was kind of erasing people. So and here you see Stalin and Yezhov, and this was kind of Stalin's one of his closest allies. And when he eventually was accused of spying, and I think admitted to at least 2 or 3 counts of spying, he was deleted from the picture. And these pictures were presented to the general public in the Soviet Union.
And they were replaced. So back then they had to do all this retouch manually.
Yeah.
And that was done by editing on top of the negative, by scraping it and adding density on top of it. So it was a painstaking process, but it worked.
Yeah, and I remember kind of growing up in Ukraine. My dad told me that sometimes they had a case when before going to a school holiday, you would get like one narrative and picture in the textbook, and then you would be coming back on the 1st of September for the new school year, and you would see something else. So definitely that's the big issue. Yeah, so just to give you a little bit of timeline, there are quite a few algorithms that we use in deepfakes, and this is probably the most recent. Most recent of them, although we do now have even more sophisticated ones that use generative AI, but they are most of them are based on these generative adversarial networks. Although we still have transformer models, autoencoders, and other types of algorithms. And some algorithms are working for video, and some algorithms are working for voice. And I think it's very important to say that a lot of people think that deepfakes are just videos of President Obama, videos of famous actors, or Trump, or whatever, But actually, you can do deepfakes of voice, and in fact, there could be a deepfake of text.
And you don't need a lot of data to train a model now. So with a few samples, you can actually recreate quite closely someone's voice. And most people will fall for it now. It's quite good now.
Yes, that's right. And we actually do quite a lot of research on this. So we have a 5-year long study where we study how people perceive deepfakes. We can talk about that shortly. But yeah, I just basically want to show you a few algorithms that we use. So for example, autoencoder could be used to generate a deepfake. Variational autoencoders, kind of next generation algorithm. You can use style-based GANs, so that's basically the network type of algorithm. You can use transformer models, and you can also use decoder models like GPT. So you can use encoder like BERT and decoder like GPT, and you can put it all in one model, and it's kind of cool. It produces really cool deepfakes. Voice synthesis technologies, so we will see a few examples today. And like I said, these are getting kind of more and more sophisticated as we go along. Yeah, so with that, let's go to the next section, which is called breakthrough. In Breakthrough, we usually discuss scientific papers. And today I don't want to concentrate on algorithmic part of it, but I want to concentrate more on how people perceive deepfakes, because there's a lot of literature. If you Google, scientific papers, algorithmic developments, you will find a lot of different algorithms that help you both generate deepfakes and detect deepfakes. So I want to concentrate on how people perceive algorithms that try to generate deepfakes. And, there are a lot of papers here and a lot of interesting advice on how to pick up a deepfake, which doesn't always work, like Alex just said. I mean, most people are getting worse. But I want to kind of concentrate on two papers. There is this paper, Deepfake Detection by Human Crowds, Machines, and Machine-Informed Crowds. It's a very cool paper because it uses a Kaggle dataset. And this Kaggle dataset is not a dataset of actors. It actually uses several volunteers who are people from general public, and they generated a bunch of deepfakes, and they're trying to give it to the participants in the experiment to understand how well they detect. And obviously, there is kind of varied success with that, but essentially people don't detect very well, even if you show them not a famous actor, but someone they haven't seen ever in their lives.
But another interesting angle here is that often people consume media using their phones. They use very small screens in noisy environments with sun glaring on the screen. Being able to pick up on the cues of a deepfake becomes really difficult because of the medium that they use to consume it. So, from this perspective, it almost requires a lab setting with controlled light and time to go through the exercise of detecting a deepfake. So, in fast-paced, crowded environments, like commuting to work, most people probably will fall for some quality deepfake without being able to discern whether it's real or not.
Yeah, that's right. But at the same time, there are also some very known failures. Like I remember a few times when Putin appeared, like during the latest Ukrainian war, like you could actually see like people putting hands through him. Like there are basically these bloopers where the deepfake was not produced, correctly, or it was a montage where they put him like as against a green screen, and then there wasn't actually a good sort of sequencing and digital sequencing when they put the video together. So there are some quite like funny things that could happen even when the video is supposed to be observed like on TV rather than on a digital asset.
But
like
fake videos have been around for a long time since video exists. So, and there is a whole area of VFX and montage and any type of combination of video sources. So that's not new. But deepfakes enable us to create something that doesn't exist or didn't exist before. And from this perspective, it becomes very, very powerful.
Right. So another paper that I want to kind of offer you to read is this one, Fooled Twice. People cannot detect deepfakes but think they can. That's a like really tiny experiment with very few people. However, it's I do really like it because it shows that people are really bad at detecting deepfakes, but they believe they're very confident that they're making the right choices.
But this is quite standard. Most people will overestimate their ability to detect errors. They will overestimate their ability to succeed, to not be fooled.
Oh, so you think it's overconfidence?
Yeah, it must be, because we observe this across the board for most things.
Yeah, overconfidence is basically a psychological, social psychology phenomenon that was first observed in driving, where in the original experiment they asked people, how confident you are that you are your driving ability is above average, and about 70% of respondents said that they were above average, but in fact only 50% can be above average. So obviously, we have huge issues with this, what we call reference group neglect. So essentially, you looking at when you're comparing yourself to other people, you believe that you are better than someone else. And equally here you just kind of trying to estimate your detection ability. So you think that it's obviously above average, fantastic, and you will be able to detect even when it's quite sophisticated technology.
Yeah, and it will be quite interesting to actually combine that with also the question of what people perceive others to do in the means of what do you think is other people's accuracy at detecting deepfakes? Because they might be overconfident, but they might be quite realistic about other people because they will be considering the group rather than themselves. So perhaps people's perception of the risk might be quite calibrated, but they have an overinflated vision of themselves when it comes to their abilities. So I think it's something to study further.
That's right. So we have done quite a large studies been running over the last 5 years, where we looked at people's ability to recognize deepfakes from different types of algorithms. So basically, all the algorithms that I mentioned earlier in this video we used in this experiment, and we will be adding some more this year because we have some new algorithms. And basically, what we found, and this is what you see on your screen, is that people's ability to detect declined on average. So there were some algorithms for which people are, the decline is not that significant, but for many algorithms, algorithms became better and people are not detecting very well. But we also give people a lot of different psychological scales and trying to measure a lot of preferences, trying to understand how do we actually increase the ability of people to detect. And one thing that is, so we do it across many different domains with different treatments, and we've done it over 5 years in several countries. And this is the essence of the finding. So we found that there are 3 characteristics that really make people very, very good in detecting deepfakes, and that's conscientiousness, emotional intelligence, and prevention focus. So conscientious people, they're very attentive to detail. So this attention to detail allows them to be quite good at picking up some of the things that we know about deepfakes that we should be looking for.
That's also known as being thorough.
Yeah, exactly. Exactly. So emotionally intelligent people, so the people who are more emotionally intelligent than others are also very good at picking up deepfakes, and preventive people, so people with what we call prevention focus. So these are people who tend to be kind of trying to minimize losses, and therefore they tend to be more cautious generally, so probably less
Maybe
trusting.
more anxious.
More anxious, yeah, maybe less trusting. And basically, yeah, we have people in the experiment who get deepfakes correct 100% of the time, so we call them deepfake sensors. And these people are a lot, so they basically exhibit all these characteristics: conscientiousness, emotional intelligence, prevention focus. They score a lot higher than the average population on this. So now we're trying to basically figure out, can we teach everyone else to pick up the deepfakes better? But I mean, these are the 3 characteristics that matter.
Well, you might not be able to train people to be more conscientious, but you might train them in emotional intelligence. So I think there is hope there. And being more prevention focused might also be trainable if you expose people to scenario planning tools or any other technique around future casting.
Brilliant. With that, we are going to go to my favorite part of the episode, and that's mixology. Now we go to my favorite part of each episode. It's called Mixology, where we're watching videos from social media, and we're having a little bit of laugh and discussing these videos. So let's watch the first video.
For every human being who looks up at the moon in the nights to come will know that there is some corner of another world that is forever mankind. Good night.
So this is the video of a deepfake of President Nixon that was produced at MIT.
In case the moon landing failed, and MIT picked the script and they recreated what it could have been.
Yeah, so it was produced by the MIT Media Lab. So it was a lot of resources went into it. So they employed an actor that was kind of recorded to reproduce kind of natural movements of the person who sits, and the voice also, like bits of the voice were used there. But essentially, this is a speech that never took place. It's completely fake, but it's extremely realistic, and a lot of people actually believe that it was a recording that was produced by or that was produced by American media of President Nixon at the time. And it just wasn't aired. So that's what we normally see. And this video is demonstrated in quite a few museums around the globe because it's such a great example of deep fake that a lot of people believe in.
Of all the aggressive, disease-spreading, viciously territorial, and habitat-ruining species in California, it is perhaps surprising that the most destructive specimen of this region would be a seemingly humble mouse. An outwardly unremarkable creature, this single mouse, named Mickey, will rise, over a relatively short time, to become the dominant mammal, subverting the usual hierarchies and laws of nature, and devouring almost the entirety of its environment.
Now we have this case of voice being faked. So we have many hours of BBC recordings from the naturalist David Attenborough. And it was possible to recreate his voice with all the nuances and all the poses and all the cadence that is expected in a good narration. And that has been done from text-to-speech AI platform that is accessible to public.
Yeah, there are actually quite a lot of tools that are accessible to public, and some of them are paid. Like you actually have to pay a little bit of a fee, but you can put like somebody's face onto a body, and it's in fact very accessible technology right now. But this is an example where you can recreate somebody's voice, and I think it's quite an overlooked possibility, because we often talk about video deepfakes, but not so much about textual or voice deepfakes, which is an example here. With that, we will go to another example. So this is a footage of a robotics lab somewhere in China. And I guess the question is like, even though the algorithms are quite well picking up the digital means, how well do they pick the physical?
Well, I think the physical means are quite far from being realistic, because most people will realize that someone is made of plastic in front of them, and body language is still not there yet. I think it will be harder for general population to be fooled by a robot that looks like a human being.
But do the developers actually have that goal to do it realistic? Because I think that there is a lot of, for example, what I noticed in terms of differences, for example, between Japan and Europe, is that in Europe, the developers never make robots that are actually try to resemble people. Whereas in Japan, I think it's like the focus is on making the robot as human-like, as realistic as possible. So there are these huge differences, I think, in among the developers.
But in Japan, robotics are quite ingrained in the culture, and I think people think it's interesting and amazing, and they probably will trust more. Whether in Europe, I think the trust in robots is quite limited. So I think developers would have a harder time to develop something that is human-like.
So sometimes, so I guess sometimes they would have this goal and sometimes they wouldn't. Yeah, quite important. Yeah, so that's this video actually claims that these robots are very human-like, but in fact, there's nothing like it.
They're
I think
quite creepy.
they're very creepy, and definitely nothing like the actual human being. Well, you can obviously see that this is not going to be. People will not be fooled by that. But I actually wanted to ask you another thing. Well, there are kind of these two concepts that we often talk about as deep fakes and digital twins. And I think, there is quite a lot of, quite a big overlap between the two, but we always distinguish between the two. And partly because I guess digital twins are more about simulating data, but you would need to simulate a lot of data for deepfakes as well. So, why do we separate these two? And I think we are consistently using more positive framing for digital twins, and consistently using a negative frame for deepfakes.
Well, the digital twin is created for the purpose of removing the need to have a human being at risk, for example, or within contexts that it will be costly or time-consuming, whilst the deep fake is often used to fake things. So I think there is probably a very wide bridge between the two. And we can definitely use the digital twin to probably create a deep fake, because it's the same data ultimately, and we just use it differently. But when it comes to digital twins, I think its purpose is mostly benign, and I have never seen digital twins being used for evil, or at least not commonly known.
Right. So, we will obviously talk about digital twins separately, but I think there's an interesting intersection there between deepfakes and digital twins that we've just talked about.
Perhaps it's worth to define what a digital twin is, because we haven't defined that yet, and probably some of the listeners might not know. So a digital twin is the amalgamation of all the data collected about someone or something that is used to recreate its model digitally, and it's meant to simulate aspects of its behavior or the whole set, depending on what it's simulating. It might be, for example, a simulation of a part on a plane, and there is a digital twin of that.
Yeah, I think the most famous one is probably digital twin of Singapore. It's the
Nice.
digital twin of the entire country. You can Google it and you will find it in 1 second. And it's pretty cool because it allows you to sort of simulate what would congestion problem look like if you build another house here, or how can you potentially solve a problem of too many people at a station if you kind of build more lines in a subway system. So it's these things are really powerful, and you can see quite a lot of examples online. Great. With that, we've covered a lot of material. There will be also quite a lot of things in the description. Obviously, look out for deepfakes. They're both interesting, amazing, and scary sometimes.
Well, quite a lot are used for humor. So that's an interesting application, which I fully support.
Yeah, I think in preparation for this, we found quite a few images of Arnold Schwarzenegger in very strange situations, I must say. But yeah, these are deep fakes for you. Thanks a lot, and we'll see you next time.
Thank you.